The distributive property. So, what the distributive property says, very simply, is that if we have a set of parentheses, anything outside that set of parentheses gets multiplied by all the stuff inside the parentheses. So, the sort of math looking version of the distributive property usually goes like this. It has an A outside and like a B plus C inside. And what it says is A multiplied by B, which we write as AB, and A multiplied by C, which we write as AC, with this plus sign in between. A times B plus A times C, which is, in my opinion, a little bit confusing. It makes a lot more sense whenever you do it like with numbers or something. So let's try a version of the distributive property with numbers. Let's do like 3 and then inside the parentheses 4 plus 2. So if I did this without the distributive property, I would do what's in the parentheses first using order of operations. 4 plus 2 is 6, right? And I would have 3 times 6, which is 18. With the distributive property, I would do 3 times 4, which is 12, plus 3 times 2, which is 6. And hey, what do you know? 12 plus 6 is 18. Now, I think a really important question to ask is, why would we use the distributor property here? Because it seems to me like it was much easier to do 4 plus 2 and then multiply by 3 than it was to do the multiplication twice and then add. The distributor property, in other words, seems like it was more work than just doing it this simple way of doing 4 plus 2. And in this problem, you're right. But as we will see, there are times where the distributor property is much faster, much more efficient. So let's go ahead and take a look at the problem we're given. And we have a table here with the cost of going to a Rice Owls baseball game. And our problem says a group of 7 adults and 6 children are going to a baseball game at Rice's Reckling Park. And we're going to use the distributor property to write and evaluate an expression for the total ticket cost. Okay, so we've got 7 adults and 6 children that are going to go to this baseball game. And I want to know, how much is it going to cost? Well, when I start off, I may think, okay, well, here's how much it costs for an adult to go, and here's how much it costs for a child to go. So let's just take the number of adults and the number of children and multiply by those ticket costs. But I notice that there is a second cost right here for when I have a group of 10 or more. If I have a group of 10 or more, it only costs $8 per ticket. And if I have 7 adults and 6 children, hey, what do you know? That's more than 10 people. So each one of these people is going to pay $8 for their ticket, regardless of whether they are an adult or a child. So before we write anything, let's think about what you would do here. We've got a total of 13 people. We do 7 plus 6, we get 13. We need to buy 13 tickets, and each ticket is going to cost $8. So we do 13 times 8, and that gives us the total cost. That is exactly what we are going to write. We're going to write that using the distributor property, though. So what did we do first? We did 7 plus 6 to get our total number of tickets. And to show that we are going to do that first, we put it in parentheses. Order of operations says you do parentheses first. So there's our 7 plus 6 in parentheses to show do that first. And then after we add those together, we multiply by 8. So we put the 8 outside the parentheses. Do 7 plus 6 first and then multiply by 8. That's if we were going to do this method right here, following the order of operations. But we're practicing distributor property here. Even if distributor property maybe is not the most efficient way to do it, we are trying to practice distributor property. So let's do it that way. Distributor property says the 8 gets multiplied by the 7. So we do 8 times 7, whatever that turns out to be. Then we do 8 multiplied by 6, whatever that turns out to be. 8 multiplied by 6. And in between these two, we use the plus sign from the problem. So we do 8 times 7 plus 8 times 6. Now, if I had a calculator handy, I could just put this in the calculator all at once, but I'm trying to do this without a calculator, so let's try that. We have 8 times 7 is 56 from our multiplication tables, and 8 times 6 is 48. And so all I need to do is 56 plus 48, and 56 plus 48 is going to be a little bit more than 100. It comes out actually to be 104. So my answer is 104, but of course I want to be a good mathematician and I want to write my answer in context. So I'm going to say the total cost is $104. And that's how we use the distributive property in this particular scenario to figure out the total cost of these 13